No matter what DAW you're using, you can use this compression technique to achieve louder, fuller mixes. You'll take a mix that sounds like this.
I get the money in a lot big K. I get the money in a lot big K. And I go bring it back,
and turn it into something that sounds like this.
I get the money in a lot big K. I get the money in a lot big K. And I go bring it back, hey. I get the money in a lot big K. I get the money in a lot big K. And I go bring it back, hey.
The difference between the first example and the second example was one simple thing, and that is parallel compression. In the first example, I played all of my tracks with my parallel compression bypassed, and in the second, I enabled all of that parallel compression so you could hear the difference. Parallel compression is when you create a duplicate of a signal in your mix, and then apply a compressor with aggressive settings to the duplicate, and then blend both versions, the dry, unaffected, and the wet, compressed tracks together. Basically, it can be used to increase the presence and punch in your mixes, creating a thicker and more glued together sound. The reason why parallel compression works so well is because it allows you to keep the dynamic or dry version of your track with all of the volume variances intact, which creates this feeling of movement and impact. Stuff that's important for dynamic sounds like the drums and vocals especially. Simultaneously, we'll blend that heavily compressed or squashed version of the same track, which reduces the dynamics but also creates a more consistent sound that's easier to hear across listening devices. This is important because not every listening device will translate those dynamics as well. And while when played on its own, the compressed version likely won't sound as good, when combined with your original dynamic track, it really helps your sound translate and cut across different listening devices, especially whether that's big speakers or small earbuds, while still retaining the feeling of your original material. Parallel compression can help glue sounds together, shape transients, and bring out more presence on sounds that need a little bit more love. I personally prefer to parallel compress my groups and my masters rather than my individual tracks directly. Really, this is just more efficient. Instead of having 10 compressors across 10 individual sounds, I could use one compressor on my drum group, for example, and achieve roughly the same thing. This is also better for gluing sounds together because I'm able to process them all together at the group level, which will improve their cohesiveness more so than compressing them individually and then trying to blend them together after the fact. So to be 100% clear, I don't usually just do this for one sound here or there, because I find that'll make that one sound stand out too much, or make it harder to sit in a dynamic mix if every other sound isn't being compressed the same way. I want synergy here, so if I do decide to parallel compress, I'm going to do it across the board, meaning my drum group, my bass group, my all instruments group, my vocal group, and usually even my master afterwards. Now, in terms of when do I actually start adding parallel compression in the mixing process, I do this after I've set all the levels within a particular group and I'm ready to start adding processing. Like in this scenario, I have all of my levels set in a mix with some slight filtering, but otherwise without any processing applied. I've just gain staged what's here and filtered out some top and bottom frequencies very lightly to focus each sound before I continue to process them. Now, I'll usually get my parallel compression going at this stage, and once that's in, I'll dive deeper and put in more processing like EQ, direct compression, saturation, and other processing directly on my channels. And that leads us to our main course. How do I apply parallel compression within my mixes? There are several ways to apply parallel compression within a mix, but what I'm going to do in this video is overview two of my favorite methods that I use all the time when it comes to parallel compression. We'll first focus on how I apply parallel compression within my groups and individual sounds, and afterwards we could take a look at how I would apply it to a master. With that being said, the first method I'm going to show you I'll call the send method. This is much more intricate than the second method I'll show you later in this video, so be sure to watch it all the way through to understand both, but this first method offers you a lot more control and therefore is my preferred method since it's the most versatile. For this example, we're going to focus on just parallel compressing the drums in my mix, but of course what I show you here is going to be able to be applied to anything else in your session. Now with this method, we're essentially going to create a return track with a compressor on it that we send all of the tracks that we want to parallel compress to. In Pro Tools, this is called an aux track, and I've already set this up on my end for time's sake, but you can see each individual sound has a send that goes to my parallel drum bus. The input of this return track should receive signal from a send from each of your individual drum tracks. All of these tracks, including the return track itself, output to to the drum group master, so they're all contained within the group basically. Now on each of the sends that are on the individual tracks, I want to do two things for housekeeping. The first is set each send so it's pre-fader, which I've already done here as you can tell because everything is blue. The pre-fader setting will allow us to solo our return track and still hear the signal being sent to the bus. If we don't do this, when we solo the return track, it'll mute all channels and we won't hear anything being sent to the bus at all. This is because all the volume is sent post-fader, and if something is muted, then you're not going to hear it at all. That's exactly what happens when you solo a channel. It mutes all the other channels. However, pre-fader gets around this, and we ultimately want to do this so we can audition the return track while dialing in our compression settings without actually hearing our dry signals. I don't want to have to hear those dry signals and hear that combination. I want to be able to just focus on the compressed signal for now. Now, because we're setting this to pre-fader, the volume of each send is going to be independent from the volume of the channel. And that means we need to do number 2, which is set the level of each fader to match the current volume of the channel. So again, as you can see here, my snare is set to -14. Therefore, my drum parallel send is also set to -14. It's mirroring this. And that's because when you set something to pre-fader, it doesn't take into account the actual level of your channel anymore. It's just going to send it at whatever level the fader is here. Basically, if I didn't have this set to pre-fader, this track would be sending at -14 plus another -14, so -28 dB, significantly quieter. But because it's being sent pre-fader, it's being sent at 0 without any gain being added or reduced. However, whatever volume I set the send to, that's the level that's actually going to be sent to my parallel track. Basically, we're doing this so that we're sending the same amount of volume to our return track and preserving our blend. This will also give us more control, as sometimes certain sounds should have less volume being sent to the return track, but we're going to talk more about this later. So assuming you've done what I've done here, which is set up all your tracks to go to this return track, and everything is sent pre-fader and every volume is matching the level of the track itself, we could solo our drum parallel bus. I'm going to make sure that my compressor is off for now. And I'm going to just play it, and I should be able to hear every single sound that I want to be sent to this return track. Let's double check that now. Assuming that you hear all sounds like I am here, we're set up and we're ready to start compressing. So with that in mind, let's get our compressor starter settings going. I'm using the Waves SSL bus compressor here. This is a very standard one, but really you just want to make sure you're using a compressor that has the same parameters, being the attack, the release, the ratio, the threshold, and the makeup gain. Now remember, our goal here is to significantly compress our material. So we're actually going to set some really aggressive settings that usually wouldn't make sense if you were directly applying this to a track. Because we're doing this in parallel, we want to use those extreme settings because we're going to end up blending them afterwards with our uncompressed, dry, dynamic track, which is going to make up for all the reductions that'll be taking place. So with that in mind, I typically set a higher ratio ranging from 3:1 to 10:1, which will significantly reduce the loudest parts of the signal that pass our threshold. Basically, the higher the ratio you use, the more aggressive the compression will be. Let's meet close to the middle in this example, and we'll set it to 4 because I only have access to 3 settings, being 2, 4, and 10. 4 right in the middle there will be the sweet spot for me today. So with a 4:1 ratio, that means for every 4 dB that goes into the compressor and passes the threshold, only 1 dB will come out. That's going to effectively cut the loudest moments into 1/4 of their volume, basically. From here, we'll set a fast attack so the compressor reacts to the material right away and works to reduce it. We want this compressor to basically flatten out any transients immediately, so we need to set it up to be fast. This is usually the quickest setting on your compressor, in this case being 0.1 milliseconds, but you could also have it somewhere between 1 to 10 milliseconds depending on your preference. If I was to do that, it would be somewhere here or as high as here. However, the further or slower we make it, the less aggressive that reaction is going to be. Therefore, I want to make sure this is super aggressive, clamping down right away. And with that in mind, I'm going to set the fastest attack time possible. Next, we'll set a slow release so the compressor hangs onto the material and keeps it reduced in volume, even if it isn't as loud anymore. This should be at least 50 to 100 milliseconds, but it definitely could be longer depending on your source material. Now, honestly, for me, I usually set the slowest setting possible to start, which I could speed up later after I have my other settings dialed in. But with the slowest setting, this will be the most exaggerated. It's going to basically keep our sounds compressed for even longer, even if it isn't necessarily passing the threshold and shouldn't be getting reduced anymore. Basically, these exaggerated attack and release settings, especially once paired with makeup gain later in the process, will effectively help us reduce the level of our transients and increase the level of our sustain on the track. This is basically what gives us a more consistent or evened out sound. With our ratio, attack, and release set, we can play our track and bring down our threshold until we start to see some some gain reduction taking place within the gain reduction meter. In this case, we want to achieve a moderate to high amount of gain reduction, which for me is usually at least minus 10 dB. Yes, this is an extreme and noticeable amount of gain reduction and won't necessarily sound good on its own, but remember our intention here to exaggerate the compression. If anything, this should actually sound like the track is significantly quieter consistently or most of the time. So let's set our threshold together to achieve that. So you can see we're achieving our targeted minus 10 dB of gain reduction. You can definitely hear that difference as well when I'm bypassing between them. You can tell that the compressed version is just sounding significantly quieter, and that means we're actually doing things right. It should sound quieter. Now at this stage, if you want, you can reevaluate your release time to create a snappier reaction. The way that I see it is the release shapes the tone of the compressor. A slow release generally makes whatever you're compressing sound rounder or smoother, since it allows the gain reduction to release a bit more gradually, which smooths out the dynamics over time. A slow release basically dulls the signal entirely, but it also makes it consistently closer in volume overall, which is my personal goal when applying parallel compression. Setting a faster release definitely could work too, and it will make the compression sound a bit more aggressive because it'll allow the compressor to quickly release the gain reduction applied during those transient peaks. So it'll basically take it down, but then go over right away and it'll come back up really fast, especially when paired with makeup gain. And what that does is it results in this sort of pumpier or more grabby sound where the transients are brought forward and the drums or other source material can have a more upfront and aggressive feel, which some people definitely like and prefer. Now, because I've exaggerated the compression sound here, my only option is really to speed up the release so it doesn't keep the material compressed as long, which might produce a more aggressive, punchier compression sound. So let's try it. Now, the real difference I'm hearing in terms of presence is I could hear the kick is obviously more pronounced with a faster release since it's not keeping things compressed, but also some of those background percussion sounds are coming forward a little bit. So for example, there's those stick type of percussion sounds. They feel a lot more in the background and a lot more reduced when I have the slower release. Again, makes sense because everything is coming down and being reduced. When I speed up the release, those stick type of sounds are coming forward a little bit more and we could hear them. They're just a lot more articulated and easier to hear. So with that in mind, we can now use makeup gain to add volume back to our signal to make up for what we're losing. It's important to consider that even though we're losing upwards of 10 dB, we may not be consistently losing that much, especially now that we've dialed down the release time. For that reason, we could focus on adding volume back through the makeup gain, but just enough so that there's no audible difference between the original track and our compressed track in terms of volume. I basically want to be able to A/B them and not necessarily hear a discernible volume difference where one is significantly louder or quieter than the other. They should roughly be matched. Of course, there's going to be some articulation differences between the two, but overall their levels should be roughly matched so when I switch between them, there isn't a noticeable volume difference. So let's add volume back using our ears. Here we go. Ultimately, I'm just trying to bridge the gap between the two, right? Before the compression, when I compared it, I could hear that the kick and the snare are definitely way more forward, way more pronounced and way louder, but all that background stuff, like those percussion sticks, for example, are not as audible. The second that I'm adding gain, those percussion sticks and everything are coming up, but the kick and the snare are way down, right? So obviously, it's not going to be 100% perfect. Again, there are articulation differences, but we want to roughly match it to our ears, and I'm sure there's other ways to roughly match the volume as well if you want to get even more scientific with it, but use your best judgment here when doing this, and of course you can always push it more later. So now with our volumes roughly matched, we can actually get to the parallel part of this process, and that is to blend the volume of our return track with our individual tracks. The way I do that is first by reducing the volume of the return track all the way down to infinite so it isn't audible. From here I'm going to play my track, which is going to be just my individual drum sounds without the parallel track, and I'm going to slowly increase the level of the return track until I start to hear and feel things thicken up. I'm also going to pay attention to my group master in the process, since the return track and all of the individual tracks are going to be going there, and I want to basically make sure that we aren't clipping or creating any other gain staging problems within the mix, and if we do, I will let you know and we can obviously address that together. And to be thorough, we can now do an A-B comparison of the track before and after parallel compression. And we can definitely hear a difference there. Now, sometimes certain sounds that you've sent to your return track will poke out a bit more than others and actually need to be reduced. And I find this to be especially true about higher end percussion sounds like cymbals and hi-hats, as they may not be triggering the compression the same way as low end sounds like the kick would be. For that reason, if I notice that something is especially pronounced, whether it's the hi-hats or something else, I'll evaluate where they're sitting in the mix and consider reducing the amount of send level I'm sending to the bus. So even though at the start I essentially mirrored the levels of my static mix, it doesn't mean that those are the levels that I have to fully commit to throughout, right? That's just a starting point that I can now reevaluate. The whole benefit of this first method is that you have a lot of control over each individual sound, so it's important to use that control to achieve a balance that you like. Otherwise, the reality is we may as well have just sent the whole group to the bus and not each channel individually. That's also actually an option you could pursue, which is definitely simpler than what I've shown you here, but again, that comes at the expense of having less control over each individual sound's presence within the compression bus. So as an example, if I find that this hi-hat is too pronounced within the parallel bus, I can go in and turn it down. I can also do the same for other sounds. Sometimes I'll even do this for my kick and my snare. So we can actually evaluate that right now. Let's try. Now you may be wondering, if we're creating a duplicate of a track and then processing it differently, won't that create phase issues? One of the big phase related issues that you're most likely to run into with parallel compression is that the compressor plugin you use may create latency. Latency is a tiny delay in timing that can throw off the compressed track with everything else in your session. In other words, your parallel compression track may seem a bit late compared to your other tracks. These timing differences can create phase issues as they're obviously out of alignment with each other, and that's a big reason why some engineers actually don't like using parallel compression at all. Thankfully, most plugins nowadays have built-in delay compensation to mitigate this, but it is still something you have to be mindful of. Now, you might notice this happening within your own sessions, and if it is, it might sound phasier, as though your mix is disjointed with multiple duplicates of a sound playing over top of each other. Let me show you one simple fix that could potentially help alleviate these problems. I do that by simply going to my drum parallel return track, and assuming that I like the balance that I have between all of my sends, I'm going to actually take this track and commit it to audio. Once the track's been committed to audio, I can actually zoom in and look at the actual waveform and identify if there actually is a timing difference. And right now you could see that where this track starts right here is the same as my kick in this example. However, if I do find that it is off timing in any kind of way, I can crop my track, and now I have just the audio right where it starts, and I'm going to find the place where the first drum hit happens, which is this kick drum in this case, and I can of course click, and I can now move it as I see fit to make sure that it is actually in line with the track that I'm affecting as well, right? So now it's basically going to cure any timing issues, and it should alleviate any of these phase issues. Of course, this is just one of several strategies, but I find that 9 times out of 10, this is the one that fixes the problem for me. Now that leads me to my second method of parallel compression, which I'm going to call the direct method. This is a simpler method which we can use to focus on our master channel, although you can easily replicate this on individual sounds and groups if you like. With this method, we want to focus on using a compressor that has a built-in dry wet knob, which of course this Waves SSL comp does as well, so we can use the exact same plugin to achieve roughly the same thing. Now this is the easiest approach because you don't need to create a send, you don't need to duplicate any tracks or do a bunch of extra steps which could be tedious or create issues if you're less experienced. Simply put it in the chain for whatever sound you want to affect, dial in your settings at 100% wet, and then reduce it to 0% and reblend to taste. Now you might be wondering, where should I put this compressor in my master chain or in the chain of my group, for example? You have a few options, but because parallel compression can drastically affect the sound's presence, dynamics, and consistency, as I've already shown you, I prefer to do it first in the chain before applying additional tonal processing such as EQ. I apply parallel compression first because I don't want the other processing to influence the sound I get out of my compressor unless there's some sort of glaring issue that needs to be addressed before we begin. So for example, if I add an EQ and exaggerate the low end, it can cause a much different reaction from a compressor than if I didn't have any lows boosted at all. However, if I notice some extremely sharp high frequencies or some muddy buildup in the low end that must be solved with an EQ, I might apply parallel compression after doing so. That being said, after you do this yourself a few times, you might prefer to add the parallel compressor later in the chain. So for example, you could put this in the middle of your chain after EQ if you want to alter a signal's tonality before compressing, or even at the end of your chain after all your processing if you prefer to further enhance your fully processed sound. So you arrive at a sound that you like without parallel compression, and then you add the parallel compression as that final cherry on top. We could set up our compressor settings very similar to before with a fast attack, the slowest release. I'm going to set a 4:1 ratio again, although again you could choose something between 3:1 to 10:1, and then I'm going to press play here and just dial in our threshold so that we're achieving roughly 10 dB of gain reduction. Basically try to get an extreme reaction out of your compressor. Let's do that together right now.
We know just how lit the street goes. I don't keep it on my side, the tradition's getting old, so I just keep close to the word that's for show. If I'm running out of ammo, I just gotta reload. Yeah, we know just how lit the street goes. I don't keep it on my side, the tradition's getting old, so I just keep close to the word that's for show. If I'm running out of ammo, I just gotta reload. Yeah.
Now with our threshold set, we can evaluate once again if we want to adjust the release time so it's quicker and has a different tonality. Let's try that out once again.
We know just how lit the street goes. I don't keep it on my side, the tradition's getting old, so I just keep close to the word that's for show. If I'm running out of ammo, I just gotta reload. Yeah, we know just how lit the street goes. I don't keep it on my side, the tradition's getting old, so I just keep close to the word that's for show. If I'm running out of ammo, I just gotta reload. Yeah, we know just how lit the street goes. I don't keep it on my side, the tradition's getting old, so I just keep close to the word that's for show. If I'm running out of ammo, I just gotta reload. Yeah.
So I'm going to leave it on the fastest release setting in this case, which is the exact opposite of where I started, but that's because this is a much more aggressive track that I think would lend itself well to this setting. I want that sort of pumpy, grabby type of reaction to really enhance the groove and just the feeling, the energy, the rawness of this track in a way. Now with that done, we can now approach using makeup gain once again to just try to roughly match what we're losing. So let's do that together.
We know just how lit the street goes. I don't keep it on my side, the tradition's getting old, so I just keep close to the word that's for show. If I'm running out of ammo, I just gotta reload. Yeah, we know just how lit the street goes. I don't keep it on my side, the tradition's getting old, so I just keep close to the word that's for show. If I'm running out of ammo, I just gotta reload. Yeah, we know just how lit the street goes. I don't keep it on my side, the tradition's getting old, so I just keep close to the word that's for show. If I'm running out of ammo, I just gotta reload. Yeah.
So that actually feels pretty close. Again, articulation differences aside, we're roughly matched. And now we can actually once again get to the parallel part of this process, but we're going to do it in a slightly different way. And that is by using the dry wet knob to blend our dry and wet signals. My goal at this stage is to fully reduce the dry wet knob down to 0 so there's no compressed signal coming in. From there, I'm going to play the track and increase it until I just start to notice the signal thickening up once again. I find this to be under 50% usually, but of course it's going to vary based on the song, so use your ears to make sure. Basically, we're going to increase the dry wet setting until you start to hear a difference, like so.
We know just how lit the street goes. I don't keep it on my side. The tradition's getting old, so I just keep close to the word that's for show. If I'm running out of ammo, I just gotta reload. Yeah, we know just how lit the street goes. I don't keep it on my side. The tradition's getting old, so I just keep close to the word that's for show. If I'm running out of ammo, I just gotta reload. Yeah, we know just how lit the street goes. I don't keep it on my side. The tradition's getting old, so I just keep close to the word that's for show. If I'm running out of ammo, I just gotta reload. Yeah, we know just how lit the street goes. I don't keep it on my side. The tradition's getting old, so I just keep close to the word that's for show. If I'm running out of ammo, I just gotta reload. Yeah.
You can hear how this is really fattening everything up and giving us the best of both worlds, as we discussed at the beginning of this video. We have our dynamics and the impact intact from the dry version of our signal, but we have more consistency as the compression is bringing out more of the sustain of our track, and really this is translating into more weight, more fullness, right? We're getting a lot more presence from our track as a result of using this parallel compression. Like I said earlier, parallel compression is one of my go-to mixing techniques to achieve louder and fuller mixes, but it isn't the only one. Click the card you see on screen right now to watch another video all about how to increase perceived loudness in your mixes. I appreciate you guys for watching. Don't forget to like the video if you got value out of it and subscribe if you're new. I'll see you next time. Peace.
5